We have the functions f of x and g of x. We want to state the domain of each function. We want to sketch the graph of each composite function and determine the range and domain of each composite function. So starting off, I'm going to make this one green and this one blue. So our domain and range of our green function, that's y equals mx plus b. You can draw a quick little sketch of it here. It has a y-intercept of 1 and a positive slope. That would be its graph. G of x, does it make sense that 4 minus x squared is the same as minus x squared plus 4? So if you think of your transformations, you have a parabola reflected over the x-axis and shifted up 4. So a quick little sketch of this graph looks like that. So our domain and range of our blue graph, again, x is everything, and y is less than or equal to 4. In A, we want to sketch what does f of g of x look like. So that means you would do g of x first, and out would come a parabola, and then you would throw that parabola into that line. And if you just think of the graphs doing that, you should have no idea what the graph looks like. None whatsoever. However, if we take the equations, if we take those two machines, those two functions, and we do g of x first, and then plug g of x into f of x, and simplify, we might come up with an equation of a graph that we know what it looks like. So what does f of g of x look like? Well, f of g of x is equal to f of, and g of x is 4 minus x squared. And f of 4 minus x squared is equal to, well, what does f of x do? It just adds 1 to it, so I would have 4 minus x squared plus 1. Simplifying that, I would have negative x squared plus 5. What kind of graph is that? That's a parabola flipped upside down and shifted up 5 units. When you're sketching a graph, again, you need to label at least 2 points. Domain and range of this black graph. Domain is everything. Range is y is less than or equal to 5. So we could only see that by coming up with the equation first and then figuring out what we would get. In B, we want to figure out what f of x is equal to. Well, f of x was x plus 1. And whatever you put into f of x, you just add 1 to. So if I put x plus 1 into f of x, I would add 1 to that. And it just becomes x plus 2. Going to graph that, it's just a straight line. And so our domain is everything, and our range is everything. Question number 4 for practice.